This is the prep packet video for Unit 4, Chapter 9.4. We're working on objective number 3, where we'll use the quotient rule for higher roots. Just to remind you, the quotient rule says that I can start with a fraction inside the radical, a fraction is the radicand, and I can split it into the root over a root. So I can take the fraction and make it a root over a root. Now, what we're about to do sort of is a matter of choice, but what I like to do, you know, I'm all about consistency. So what I like to do first is try to handle it vertically. I want to see if 3 will fit into 81. In this particular case, before you get too alarmed, yes, that's a negative sign, but it's okay because this, the index, is odd. If it were even, I would stop because it was not a real number. But I can keep going. But let's go back to dealing with this fraction. 3 goes into 81 27 times. Trust me. So my new version is the cube root of negative 27. And because it's a cube root, it's going to come out as negative 3 cubed. Since these are the same, what comes out is negative 3. That's this simplified gives me that. Here, and again, remember, because even though I have a radical over a radical, it still can be treated like this first. So I have the cube root of 96 over 2. Again, I like to work vertically first to see if I can deal with that, and I can. So let's see, 2 goes into 96, 45, 48 times. So now I just have to deal with the cube root of 48. And I remember that that is the same as 3 times 16. And 3 times 16 would be 2 to the 4th. That's kind of the long way to do it because it's really 6 times 8, and 8 is the cube root, is 2 cubed. Okay, sorry, let me start again. 48 is 6 times 8, and 8 is 2 cubed. So I'm going to rewrite that as the cube root of 2 cubed times 6. And because those are the same, that can come out. So I have 2 root, cube root, 6. And that's my simplified version of what I started out with. I chose to do my division first because it was a lot easier to figure out for me. And again, I'm really into consistency. I want to try the same thing all the time, and only if it doesn't work, then do I move on. So let's take a look at some of these guys. Here I have the 4th root of 48 over 3. Well, I'm going to simplify first because I can, and that'll give me 3 goes into 48 16 times, and 16 is 4 cubed, 2 cubed, sorry. So the answer is 2. Remember, that's because this is the same as, and when those are the same, that comes out. Let's take a look at this next one. Here, I can rewrite that as the cube root of 56 over 2, which is the same as the cube root of 28. And the cube root of 28, so that would, let's see, that would be 7 times 4. No cube roots there, so I'm done. And that's my final answer. Let's take a look at this last one. Now here, we are dealing all with variables, and there's a couple ways you can do this. You can do it in your head and know that 6 goes into 12 two times, so out comes f squared, and 6 goes into 24 four times, so out comes g to the fourth. These are not the same bases, so I have to stop. The other way you could think about this is 6 over f to the 12th root 6 over g to the 24th. And again, you'd come back with 6 goes into. It sort of just depends on how you want to organize your head. You can also rewrite this as f to the 12/6 over g to the 24/6. However you're going to do it, there's a little division involved with these exponents. This is a really good example, though, why using fractional exponents gives it a little more clarity. So finally, for more practice, I want you to do the U-tries on page 545 and include your work with the prep packet. Thanks a lot, and we'll see you in the next video.